Yes, I think my screen is visible. Okay, let us start our session. Good evening, students. Again, it is structure of atom. See, in the structure of atom, in the last class, we have studied up to concepts, electromagnetic radiations and its characteristics of electromagnetic radiation. Now, in this class, let us move on to what is electromagnetic spectrum. So, what is then electromagnetic spectrum? The electromagnetic spectrum may be defined as the arrangement of different electromagnetic radiations in order of increasing or decreasing frequency. It is arrangement of different electromagnetic radiations in the order of increasing or maybe decreasing order of its frequency. It is systematic arrangement of electromagnetic radiations. In the prayer in your school, ಹೇಗೆ ನಿಲ್ಲಿಸ್ತಾರೆ ನಿಮ್ಮನ್ನ based on increasing order of your height. ಹೌದಿಲ್ಲ? Similarly, the arrangement of radiations in increasing order of their height ಅನ್ನು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ ಇಲ್ಲಿ frequency, then we call it as electromagnetic spectrum. And different rays are having different electromagnetic spectrum. Here, for gamma rays, it is about 10 raised to 10 raised to minus 12. 10 raised to minus 22 12 meter. It is less than 10 raised to minus 12 meter. Its frequency, gamma ray frequency is very smaller. That is 10 raised to minus 12 meter ಇಂತ ಕಡಿಮೆ ಇರ್ತದೆ. For X-rays, it is 1 nanometer, 1 nanometer to 1 picometer. It is picometer, 1 nanometer to 1 pico. Pico is 10 raised to minus 12 and is 10 raised to minus 9. It is 10 raised to minus 9 meter to 10 raised to minus 12 meter. Then visible ultraviolet rays. These are having 400 nanometer to 1 nanometer range. And visible here, this one is important for us. It is 750 nanometer to 400 nanometer. What are these visible light that visible to our eyes? They are called as visible rays. So near infrared and far infrared region we call both as infrared region. It is 2.5 micrometer. Micro means 10 raised to minus 6. It is micrometer. To 2.5 25 micrometer, 2.5 micrometer is the range of infrared radiation. Microwaves, these are 1 millimeter frequency. Wavelength range is 1 millimeter. We are discussing all these are nothing but wavelength ranges. These are wavelength ranges, these are frequencies. Now usually frequency just wavelength ಅಲ್ಲಿ ಹೇಳಿರ್ತೀವಿ, ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಡುವಾಗಲೂ wavelength ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ. 1 millimeter to 25 millimeter. And radio waves are having highest wavelength, that is greater than 1 millimeter. These are having highest wavelength greater than 1 millimeter for radio waves. Then comes our electromagnetic radiations. See here, there are 7 types of electromagnetic radiations are there. 7 types. What are they? Already we have discussed that radio waves, microwaves, infrared and visible rays, then ultraviolet, X-rays and gamma rays. See here, this radio waves, what we use in radio frequencies, they are nothing but radio waves. Now waves na use ಮಾಡ್ತೀವಲ್ಲ, TV connection ಇರ್ಬೋದು, radio connection, they are nothing but radio waves. Then what are microwaves? Microwaves that we use in micro ovens. Micro ovens ಅಲ್ಲಿ use ಮಾಡ್ತೀವಲ್ಲ, they are microwaves. And infrared regions, ನಮಗೆ ಸಿಟ್ಟು ಬಂದಿದೆ, ಮೈಯೆಲ್ಲ ಬಿಸಿ ಆಗ್ತಿದೆ. What is the reason? Because infrared radiations are emitting out of our body. ಮೈಯೆಲ್ಲ ಬಿಸಿ ಆಗ್ತದೆ, ಕೆಂಪಾಗ್ತೀವಿ ಸಿಟ್ಟು ಬಂದ್ರೆ, ಡ್ಯೂ ಟು ಇನ್ಫ್ರಾರೆಡ್ ರೇಡಿಯೇಷನ್. ದೆನ್ ವಾಟ್ ಈಸ್ ವಿಸಿಬಲ್ ಸ್ಪೆಕ್ಟ್ರಮ್? Visible spectrum are nothing but these rainbow colors. These are called as visible spectrum. Red, we know that Vib or Vib, violet, indigo, blue, green, yellow, orange and red. These are the visible region. 400 nanometer to 750 nanometer range. This is the range of wavelength of visible spectrum. And we observe these colors, and some different colors we observe, that is due to mixing of these colors. Let it be. Then this is ultraviolet. You are aware of ultraviolet rays, because ultraviolet rays usually ಏನ್ ಹೇಳ್ತಾರೆ, ಮಧ್ಯಾಹ್ನದ ಬಿಸಿಲಿಗೆ ಹೋಗಬಾರ್ದು, ಕ್ಯಾನ್ಸರ್ ಬರ್ತದೆ. Why? Due to ultraviolet radiation. Then X-rays, of course, all you should aware, that is X-ray. X-ray photography, ಏನಾದ್ರೂ ಫ್ರಾಕ್ಚರ್ ಆದಾಗ ಮೆಡಿಸಿನ್ ಅಲ್ಲಿ ಅಥವಾ ಹಾಸ್ಪಿಟಲ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ, ದಟ್ ಈಸ್ ಎಕ್ಸ್ರೇ ಫೋಟೋಗ್ರಫಿಗೆ ಎಕ್ಸ್ರೇ ಅನ್ನ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ಅಂಡ್ ಗಾಮಾ ರೇಸ್, ದೀಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್, ಈಗ ಕ್ಯಾನ್ಸರ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ವಿದೌಟ್ ಸರ್ಜರಿ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ದಟ್ ಈಸ್ possible by this gamma rays. These are having very high energy. Gamma rays are having very high energy. These are electromagnetic spectrum. See here, gamma, X-ray, this UV, visible, infrared, microwaves and radio waves are increasing order of their wavelengths and decreasing order of their frequency. Why increasing order of their wavelength and why decreasing order of their frequencies? Because we know that nu is inversely proportional to lambda. Lambda is here wavelength. This is frequency. Frequency is inversely proportional to wavelength. Next one is Planck's theory. What is Planck's theory. And who is Planck? Planck is a scientist who gave that light consists of light is made up of particles which are packets of energies. Light is made up of packets of energy called as quanta. Quanta is its plural form, whereas quantum is its singular form. According to Planck's quantum theory, light is made up of both wave and particle. We know that in the last class we have studied, according to Maxwell, electromagnetic radiation, light waves are made up of waves. Light are made up of waves, he said. But here Planck says that light is both particle as well as wave, and they are nothing but packets of energy. While interacting with material or objects, they act like particle, but while traveling or while propagating, they act like wave. According to this theory, energy cannot be absorbed or released continuously, but it is emitted or released in the form of small packets called as quanta. It is called as quanta. ಹೇಗೆ ನಮಗೆ ಲೇಸ್ ಪ್ಯಾಕೆಟ್ ಅಥವಾ ಕುರ್ಕುರಿ ಪ್ಯಾಕೆಟ್ ಅಂಗಡಿಯಲ್ಲಿ ನೇತು ಹಾಕಿಟ್ಟಿದ್ದು ಒಂದೇ, ಬಟ್ ದೇ ಆರ್ ಡಿಫರೆಂಟ್ ಗೇಟ್ಸ್. ಅದೇ ತರ ಇಲ್ಲಿ ಎನರ್ಜಿ ಏನಿದೆ, ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ ಇಸ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎನರ್ಜಿ. ವೈಲ್ ಟ್ರಾವೆಲಿಂಗ್ ನಮಗೆ ಅದು ಒಂದೇ ತರ ಕಾಣ್ತದೆ, ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಅನಿಸ್ತದೆ, ಬಟ್ it is not continuous. Different packets will be there. In case of light, ನಾವು ಕ್ವಾಂಟವನ್ನು ಫೋಟಾನ್ ಅಂತ ಕರಿತೀವಿ ಅಷ್ಟೇ. Quanta is called as photon in case of light. And he gives the relation between frequency and energy. He says that energy is directly proportional to frequency. Energy of the photon is directly proportional to its frequency. Therefore, he gives the equation E is equal to h nu. This is equation of Planck. E is energy of that packet. In packet formally energy flow ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, it is form of energy form, energy packet. ಈ ತರ ವೇವ್ ತರ ಪ್ರೊಪಗೇಟ್ ಆಗ್ತಾವ, ಬಟ್ ನೋಡ್ಲಿಕ್ಕೆ ದೇ ಆರ್ packets or particles of energies. This h is nothing but Planck's constant. Its value is 6.626 into 10 raised to minus 34 joule second. And nu is, you know, it is frequency. This is about Planck's quantum theory. So Planck's quantum theory came to exist because the scientist observed photoelectric effect and black body radiation, which could not be explained using this electromagnetic radiation wave character of the light. ಅದಕ್ಕೆ this Planck's quantum theory came to exist. So let us discuss what is photoelectric effect and what is black body radiation. See here, this photoelectric effect is interesting subject where when the light of suitable frequency falls on the metal, there is ejection of electrons takes place. This phenomenon is known as photoelectric effect. And the electrons which are ejected at this time are called as photoelectrons. These electrons are called as photo electrons. These are photo electrons. See, ಇಲ್ಲಿ ನೋಡ್ರಿ, ಸಣ್ಣವರಿರುವಾಗ ಗೋಲಿ ಆಟ ಆಡಿರ್ತೀರಿ. ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಇದನ್ನ ಗೋಲಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ರಿ, ಇನ್ನೊಂದು ಗೋಲಿನ ನೀವು ಹೊಡಿತಿದ್ದಾಗ ಏನಾಯ್ತು, ಗೋಲಿಗೆ ಹೊಡೆದಾಗ ಈ ಗೋಲಿ ಏನಿದೆ ವಿಚ್ ಇಸ್ ನಾಕ್ಡ್ ಔಟ್ ಫ್ರಮ್ ಇಟ್ಸ್ ಪೊಸಿಷನ್. ಸಿಮಿಲರ್ ಪ್ರೊಸೆಸ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್. ದಿಸ್ ಇಸ್ ದ light which is falling on the metal surface. This metal surface fall ಆದಾಗ ಏನಾಗುತ್ತೆ, using this energy due to the high frequency of this radiation, this electron present in the metal is kicked out. Electron is kicked out from the metal surface. Therefore, this is called as photoelectric effect. Photo means light. Photo means light, and elect refers to some electrons. Photon light So the electric refers to electrons, and effect which relates both photo means radiation and electrons. This is photoelectric effect, and this cannot be done or explained using the concept, that is classical concept, which is given by Maxwell, because here, what are the observations that done during photoelectric effect? Only photons of certain minimum frequency called threshold frequency can use cause photoelectric effect. You should have some certain minimum energy. Why? Because ಈಗ ನೋಡ್ರಿ ನೀವು ಒಂದೂರಿಂದ ಒಂದೂರಿಗೆ ಆಟೋದಲ್ಲಿ ಹೋಗ್ತಿರ್ತೀರಿ. ಆಟೋದಲ್ಲಿ ಹೋಗುವಾಗ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದ ಮಿನಿಮಮ್ ಪ್ರೈಸ್ ಆಫ್ ಆಟೋ ಡ್ರೈವರ್ ಇಸ್ 100 rupees ಅಂತ ಇಟ್ಕೊಳ್ಳುವ. ಇಫ್ ಐ if I would like to give him 99 rupees, he will not convinced. The minimum price is 100. He say minimum price is 100. Without that amount, he refuses to come with me. Therefore, similarly, that falling frequency should have some minimum frequency. It is different for different metals. That threshold frequency is different for different metals. So, if threshold frequency is fallen on the metal surface, then only photoelectric effect is happened. Nu naught, it is nu naught, it is different for different metals. And kinetic energy of the electrons which are emitted, you know, emitted, the electrons will be having some kinetic energy. This kinetic energy depend on intensity of the light falling. What is the intensity of this light falling? Based on that, this kinetic energy, ejected electrons will be having some kinetic energy. It is given by incident energy equal to work function plus kinetic energy. Threshold frequency is but work function. Threshold frequency is called as work function. This, it is utilized to work functions. Is utilized threshold energy or work function. The remaining energy is converted to kinetic energy. H nu, incident energy may be represented as H nu, because we know that E, energy is equal to H nu, concept. E is equal to H nu. H nu naught and E naught and the if it is E naught plus half mv square is kinetic energy. Nu naught is threshold frequency. Nu is frequency of incident radiation. It is frequency of incident radiation. H is Planck's constant. In kinetic energy, half mv square, mass, it is mass of electron, ejected electron, and velocity of ejected electron. The number of electrons that are ejected per second from the metal surface, it is number of how many number of electrons are ejected per second, that depend on metal, the photons which are striking the metal surface, number of photons. The number of electrons ejected is depend on number of photons. Here it is intensity of striking photon is nothing but it is brightness of the light. ಎಷ್ಟು brightness ಅಲ್ಲಿ light ಬೀಳ್ತಿದೆ, based on that number of ejected electrons will be more or less based on that intensity. It is very important. You should remember number of ejected electrons depend on intensity of photon, whereas this kinetic energy depend on frequency. These two are important. Next one is black body radiation. What is black body radiation? Here, what is initial? What is black body? Black body is the ideal body which absorbs and emits all frequencies of radiation. They are called as black body. And the radiation emitted by the body, this black body is known as black body radiation. Here, the ideal body. This is actually hypothetical body, because in the universe, not any body that can emit or absorb all range of frequencies of radiation, because it is very wide range. You know, the range between gamma rays and radio waves, it is highly very high or vast range. Therefore, there is hypothetical, it is hypothetical body. But carbon black, it is called as ideal body. It is approximately called as ideal body, not exactly. And they consider a spherical body which is having a small hole, only a small hole, but not having any exit hole. Therefore, when light enters into it, which reflects inside this body, therefore there will be no emission. So they consider this type of body as approximate black body. At a given temperature, the intensity and frequency of the emitted radiation depends on temperature. The intensity of the radiation or frequency, that depends on in which temperature the frequency we are using. Here, see here, when you heat iron rod, first initially at lower temperature you observe red color. Then if you heat it further, or if you increase the temperature further, then what happens? The color changes to green. If you further heat it, the color changes to white. Then it changes to violet or bluish color, which means the intensity or the frequency of the emitted radiation, what we are observing, that colors are nothing but called as these emitted radiations. Therefore, this emitted radiation depends on temperature. The frequency depends on temperature. At given temperature, the intensity of radiation emitted increases with decrease of wavelength. Why decrease of wavelength? Because we know that it increases with frequency, increases with the temperature. Therefore, frequency and wavelength are inversely proportional. They are inversely proportional. Therefore, what happens? This, as frequency increases, lambda should decrease. Therefore, with decrease of wavelength, as temperature increases, the intensity of radiation emitted increases with decrease in wavelength. Decrease of wavelength. ಯಾವುದೋ ಒಂದು ಟೆಂಪರೇಚರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ರೇಡಿಯೇಷನ್ ಏನಾಗ್ತದೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ ವಿತ್ ಡಿಕ್ರೀಸ್ ಆಫ್ ವೇವ್ಲೆಂತ್ ಆರ್ ಇನ್ಕ್ರೀಸ್ ಆಫ್ frequency. Both are interrelated. This is about black body and black body radiation. And Bohr's model. Based on this observation, Bohr introduced his atomic model called as Bohr's model. So, what is Bohr's model? Bohr is a scientist who introduced his atomic model. An atom consists of dense stationary nucleus situated at the center. Nucleus is placed at the center. And atom is spherical in shape. The electron revolves around the nucleus in a circular orbits without emitting energy. See here, electrons are revolving around this nucleus in an atom without emitting energy. They are not emitting any energy. They are not emitting any energy while revolving. The force of attraction between the nucleus and the electron is equal to centrifugal force. So, centrifugal force is nothing but the force which is exerting away from the nucleus, which is centrifugal force. That centrifugal force is due to rotation of electron, revolving of electron around the nucleus, whereas centripetal force, which counteracting the centrifugal force, is by this nuclear charge. We know nucleus having positive charge. This positive charge attracts this electron towards itself. This is act as centripetal force. Then, out of many circular orbits, there are many circular orbits are there. Out of these many circular orbits, what he says, an electron can revolve only in those whose angular momentum MVR, if studied in physics, angular momentum is MVR, is integral multiple of h by 2 pi. It is given by MVR is equal to NH by 2 pi. N is nth orbit, whether it is first orbit, second orbit, here, whether it is first orbit present in first orbit, second orbit, based on that, n is multiplied. So he says that just like it is, we call it as quantized energy, or the angular momentum is quantized. Meaning, after studying first standard, we have to study, or we have to promote it to second standard, 1.5 standard, or 1.2 standard. There is no possibilities. One first standard ಆದ್ಮೇಲೆ second standard. ಅದೇ ತರ first staircase ಆದ್ಮೇಲೆ second staircase I have to climb. Now 1.5 staircase ಹತ್ತೀನಿ, it is not possible. Similar to that one, electrons are revolving in first orbit, or second orbit, or third orbit. No 1.5th orbit, no 1.2 orbit, or 2.5 orbit. These are not possible. That is the meaning of this statement. Since electron revolving in an orbit neither loses nor gains energy, hence these orbits are called stationary states. These are called as stationary states, which means electrons are, it doesn't mean that electrons are static, but stationary states meaning, the energy is not released or not absorbed when electron in its revolving in its orbit. Each stationary state is associated with a definite amount of energy and also known as energy levels. These stationary states are also called as energy levels. First energy level, second energy level. If another orbit is present, then it is called as third energy level, like that. So these are the statements of Bohr's atomic model. Then here, these are the postulates, important postulates of Bohr's atomic model. Then, how to find out radius of the orbit? We know that nucleus is at the center and electrons are revolving around the nucleus. And if I consider this as a spherical, atom is a spherical, we know. Therefore, what is the radius of this orbit? What is the radius? Here, how to find out the radius of the orbit? This is the equation. N square h square divided by 4 pi square m k into z into e. This is the equation to find out the radius. No need to by heart this one here. This simplified way to find out Bohr's or radius of the Bohr's orbit is equal to r is equal to, simplify ಮಾಡಿದಾಗ ಎಲ್ಲ values ಹಾಕಿ simplify ಮಾಡಿದಾಗ its value is 0.529 angstrom ಅಂತ ಬಂದಿರ್ತದೆ. Angstrom is 10 raised to minus 10 meter. Angstrom will be equal to 10 raised to minus 10 meter. And n square by z ಅಂತ ಹೇಳ್ತೀವಿ. Here, n square, n is nothing but orbit. Which orbit? Whether it is first orbit or whether it is second orbit or third orbit. We have to substitute the value of n. What is z? Z is atomic number. Z is atomic number. For hydrogen it is 1. For helium it is 2. Lithium it is 3. Atomic number, which will be in angstrom. How to find out the velocity of electron in an orbit? V is equal to 2.18 into 10 raised to 8. 2.18 into 10 raised to 8 into n by z. This is constant value. 2.18 into 10 raised to 8, it is constant value, whereas n by z. N is again number of orbit, which orbit the electron is present, and z is its atomic number. Next, how to find out the energy of electron in an orbit. Okay, electron is present in one orbit. How to find out its energy? Here, this is the formula. E is equal to 2 pi square m into z square e raised to 4 into k square divided by n square into h square. Again, by substituting all the values, they found that energy equal to minus 2.18 into 10 raised to minus 11. This constant only when the unit is in urge per atom. If it is urge, then only it is 10 raised to minus 11. If it is joule per atom, then it is minus 2.18 into 10 raised to minus 18. This is going to be changed. And into z square by n square. Z square is again atomic number. Which atom? If it is given for hydrogen, we have to substitute z is equal to 1 for hydrogen, and n is equal to 1, 2, 3, 4 possible for different orbits. If the energy is asked in terms of electron volt, then we have to substitute minus 13.6 as the constant. Minus 13.6 into z square by n square. This is the constant value we have to substitute. This is the formulas. These are the formulas to find out energy in terms of urge, electron volt, and joules. Let us solve one problem. Calculate the radius of third orbit of lithium 2 plus ion. This is the question they have asked. In this case, see here, they have asked the radius. Radius, we know the formula to find out radius. Radius r is equal to n square by z. This is the formula. Into 0.529. 0.529 is nothing but it is first orbit, or it is constant. It is the radius of first orbit. 0.529 angstrom is Bohr's orbit radius ಅಂತಾನು ಹೇಳ್ತೀವಿ ನಾವು ಇದನ್ನ, radius of first orbit. We have to multiply it with n square. First, while solving the problems, to understand the problem, first you have to write what are the given entities. N is equal to 3. Third orbit anta kelidare, therefore n is equal to 3. And lithium, they have asked lithium, therefore Z will be equal to hydrogen, helium, lithium. Lithium is third element, therefore atomic number is 3. We have to substitute here n is equal to 3. It will be 3 square divided by z. 3 square, 3 into 3 will be 3 square divided by z is again 3 into 0.529 angstrom. Answer will be 1.587. Try it. This will be our answer. Armstrong is nothing but again it is 10 raised to minus 10 meter. 10 raised to minus 10 meter is equal to angstrom. Next one. Based on energy. Calculate the energy with the first orbit helium plus and what is its radius of the orbit. First they have asked the energy. Again we know the formula for the energy. Energy is equal to, in terms of joules, it is minus 2.18 into 10 raised to minus 18 by n square. And in the numerator it is z square. This is the formula. Now again, what are the given here? And they have given as first orbit. First orbit, therefore I have to take n is equal to 1. And helium plus 1 is given, which means is for helium, hydrogen, helium. Helium it is 2. Z is equal to 2. Minus 2.18 into 10 raised to minus 18. Z square. Z square is 2 square, which is 4. And n square is 1 square. Square andre ಏನು ಮಾಡೋದು? 2 square equal to 2 into 2, which is 4. And answer will be minus 8.72 into 10 raised to minus 18 joule. This is the answer. Then also they have asked the radius. Radius, therefore, again, same as previous problem, radius is equal to 0.052 nanometer into nanometer, 0, therefore it is nanometer. You can also take it as 0.529 angstrom into n square by z. N is 1 square divided by z is equal to 2. Therefore, this will be the answer. ಏನು ಮಾಡಬೇಕು? You have to multiply 0.0529 into 1. 1 into any number will be equal to that number divided by 2. Calculator ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಇಲ್ಲಿ ಯಾವ ತರ ಮಾಡೋದು? 2 square. 2 square ಮಾಡ್ರಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಇಂಟು 2.18 ಮಾಡ್ರಿ. ಆನ್ಸರ್ ಎಷ್ಟು ಬರ್ತದೆ? ಇಷ್ಟು ಬಂದಿರ್ತದೆ ಆನ್ಸರ್. 10 raised to minus 18 as it is ಬರೆದ್ರೆ ಆಯ್ತು. This is how we have to solve problems on energy and radius of the orbit. These problems are very important and they will be asked in the examination. Then, what are the limitations of Bohr's theory? Then, what are the limitations of Bohr's theory? So, the first limitation is Bohr's atomic model failed to account for splitting of spectral lines in magnetic field. Here, what are spectral lines? We are going to study spectral lines. See, let us consider a light ray is there. ನಾನು ಇದನ್ನ ಈ ತರ ನೋಡ್ತಿದ್ದೀನಿ ಲೈಟ್ ರೇ. ಬಟ್ ವೆನ್ ಸೈಂಟಿಸ್ಟ್ ಯೂಸ್ಡ್ ರಿಸಾಲ್ಟ್ ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪ್ ನೋಡಿದಾಗ ದೇ ಅಬ್ಸರ್ವ್ ದೇರ್ ಆರ್ ವೆರಿ ಫೈನ್ 2 lines are there, but they are looking like a single line, but there are many fine lines are there, and these fine lines cannot be explained by Bohr. Why these very fine lines are observed in case of spectrum? And he couldn't explain Zeeman effect and Stark effect. What is Zeeman and Stark effect? It is splitting of the spectral line in magnetic field. If it is splitting the spectral line, if it is splitting in magnetic field, when I apply north and south poles, at that case, if it is splitting, then we call it as Zeeman effect. If the spectral lines splits in electric field, then we call it as Stark effect. If it is plus, if it is minus, then they are splitting, the line is splitting, then we call it as Stark effect. And another objection is there, it is against Heisenberg's uncertainty principle. Just remember this one, Heisenberg's uncertainty principle. We are going to discuss what is Heisenberg's uncertainty principle. This Bohr's atomic theory is against to Heisenberg's uncertainty principle. Here, spectrum. What is spectrum? It is arrangement of light. Arrangement of light in a systematic order is called as spectrum. This is called as spectrum. This is continuous spectrum, and these are discontinuous spectrum. Continue idre continuous spectrum, discontinue idre discontinuous spectrum. What are the types of spectrum? Emission spectrum. What is emission spectrum? See here, emission spectrum is nothing but when, okay, let us consider one analogy. ಈಗ ಕಾಮನ್ ಪೀಪಲ್ ಒಬ್ರು ರಾಷ್ಟ್ರಪತಿ ಆಗ್ತಿದ್ದಾರೆ. ಸೊ ಹಿ ಈಸ್ elected to president. At that time ಏನಾಗ್ತದೆ, he will be allotted with house, Rashtrapati Bhavan, some guards, and vehicle, government vehicle. But while he has to emit from his position after 5 years, president idaru ಮತ್ತೆ common man ಆಗ್ತಾರೆ. At that time the guards no more remain with them, and that rashtrapati bhavan no more of theirs, and that government vehicle they have to emit. This is called emission. Similarly, electron, if they are, if this is nucleus and this is first orbit and this is second orbit. ಈಗ electron in the first orbit, it is jumped to second orbit ಅಂತ ಇಟ್ಕೊಳ್ಳುವ. And now while emitting energy, it has to jump back to its original orbit. Any substance on heating gets excited on absorbing energy or at a very high temperature or after, with radiations are emitted from the substance. The radiations, when analyzed with the help of spectroscope, when they are analyzed while these electrons are jumped back to their original state or original stationary state, some radiations will be observed. Illenagtade, they emit some radiation. If this is radiation, they emit some radiation. And this radiation, when they passed through the prism, you know the prism you have already studied. So when they passed through prism, they observed only certain lines are present. You'll nodri. In case of helium, very yellowish line will be there. And for iron, different red color zone, yellow color, and blue color, violet color zones, different lights are emitted. What happens? Consider if you are heating iron rod heat ಮಾಡಿದಾಗ ಏನಾಯ್ತು? It is emitting some radiation. You observe when iron rod is heated, it turns to red color. That red color, when passed through the prism through pass ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ? They observe these lines. ಈ lines observe ಮಾಡಿರ್ತಾರೆ. This is called as emission spectrum. Then the next spectrum is absorption spectrum. Here, when incandescent substance is passed through other substance, these substance absorb some radiation, particular wavelength, radiation of particular wavelength from the white light. Consider here sodium chloride is there. It is sodium chloride. I am passing white light through this sodium chloride. I am passing the white light through sodium chloride solution, with this solution. Then when, again, you know, while passing through this sodium chloride solution, some radiations are coming out from this solution. And when I pass this solution through the prism, and scientists observed some yellow lines ಅನ್ನ observe ಮಾಡ್ತಾರೆ. So this is called as absorption spectrum. See here, absorption spectrum, some are missing. In absorption spectrum, some lines are missing. And in emission spectrum, under the black background, the lights are emitted. See here, the surprising thing is, whatever the light here absorbed, or whatever the wavelength the light absorbed, at that wavelength only light are emitted. Yavaga absorb ಆಗ್ತದೆ? Again, this is nucleus and electron in its ground state, and electron want to go its higher state. It require very high energy to go to this second orbit. So if I heat this atom or supply some radiation, at that time it absorbs some energy and go to higher energy level. This electron jumps to higher energy level. At that time it has to absorb this energy. See, when I pass this white light is nothing but form of energy. When I pass this white light through this substance, these electrons get to this energy level, and here they absorb some radiations. And while coming back, this is highly unstable. Excited state is very unstable. ಯಾರು ನಮ್ಮನ್ನು ಹೊಗಳ್ತಾರೆ, ನಾವು ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ ಇಂದ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಎಕ್ಸೈಟ್ ಆಗಿಬಿಡ್ತೀವಿ, ಬಟ್ ಇಟ್ ಈಸ್ ವೆರಿ ಅನ್ಸ್ಟೇಬಲ್. ವಿ ಹ್ಯಾವ್ ಟು ಕಮ್ ಬ್ಯಾಕ್ ಟು ಅವರ್ ಲೋವರ್ ಎನರ್ಜಿ ಸ್ಟೇಟ್. ಹೌ? ಬೈ ಎಮಿಟಿಂಗ್ that ಎಕ್ಸ್ಟ್ರಾ ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ವ್ ಮಾಡಿದ್ವಲ್ಲ, ಆ ಎನರ್ಜಿನ ಎಮಿಟ್ ಮಾಡಿ ground state ಗೆ ಬರೋದು. And this is nothing but emission spectrum, and these lines absorbed are absorption spectrum. So this emission and absorption spectrum, here emission spectrum is also called as line spectrum or atomic spectrum, line spectrum and emission spectrum. When electromagnetic radiation interacts with matter, atoms and molecules may absorb energy, that one, and reach to higher energy state, which is unstable. Higher energy state is unstable. For returning to their normal state, that is more stable state, the atoms and molecules emit radiations. Without emitting, they can't reach to their original state. In various regions of the electromagnetic spectrum, these lines constitute the atomic spectrum of the element. See here, different lines are emitting from different orbit. ಇಲ್ಲಿ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗ್ಲಿ ಅನ್ನೋದಕ್ಕೆ ಸರ್ಕಲ್ ಹಾಕೋದ್ರ ಬದಲು ಲೈನ್ಸ್ ಅನ್ನ ಹಾಕಿದ್ದಾರೆ. These are different orbits: 7th orbit, 6th orbit, 5th orbit, 4th orbit, 3rd, 2nd and 1st orbit. Electrons which are at higher energy levels jumping to the lower energy levels. This is atomic spectrum. And here this one is very important, that is hydrogen spectrum. What is hydrogen spectrum? The spectrum observed by hydrogen is called as hydrogen. When electrons in the hydrogen are absorbed some energy, and while emitting back, they emit energy in the form of radiation of different wavelength or frequency range, that we call as hydrogen spectrum. So here different orbits are having different energy levels. See here, minus 13.6 into z square is for first orbit. If it is second orbit, minus 3.4. See here, minus 13 is smaller than minus 3.4 because minus sign is there. Therefore, second orbit having higher energy compared to first orbit, whereas third orbit again having higher energy, minus 1.51, which is higher compared to minus 3.4 electron volt. Now, see here, this is hydrogen spectrum. Very important hydrogen spectrum. Here, you know that in hydrogen, electrons will be always in first orbit. Electrons will be always in first orbit, and they are absorbing some energies, maybe by heating or by absorbing light. They jump to higher energy levels, maybe second orbit or maybe third orbit or to the fourth orbit, whatever, up to infinite level, they may jump to any of the orbit. This is absorption. But while emitting back, they may jump to first energy level, that is first orbit, or they may emit to second orbit, or they may emit to third orbit, and so on. Here, let's consider this as apartment. And you are in the apartment, elevator alli you are landing to the first orbit. First orbit ಅಲ್ಲಿ ಲ್ಯಾಂಡ್ ಆದ್ರೆ ನಮ್ಗೆ ಯಾರು ಸಿಗ್ತದೆ? ಲೈಮನ್ ಅಂಕಲ್ ಮನೆ ಸಿಕ್ಕಿರ್ತದೆ. ಈಗ ನಾನು ತಪ್ಪಿ ಸೆಕೆಂಡ್ ಫ್ಲೋರ್ ಅಲ್ಲಿ ಇಳಿದೆ ಅಂತ ಇಟ್ಕೊಡ್ರಿ. ಸೆಕೆಂಡ್ ಫ್ಲೋರ್ ಅಲ್ಲಿ ಇದ್ರೆ ನನಗೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಬಾಮರ್ ಅಂಕಲ್ ಮನೆ ಇದೆ. ಥರ್ಡ್ ಫ್ಲೋರ್ ಅಲ್ಲಿ ಇಳಿದ್ರೆ Passion. Fourth floor is for bracket. Fifth is for P fund. Sixth one is for hum fairy. See here, similarly, electrons when jump from any energy level to the first orbit, then we call it as Lyman series. If electrons jumping from any orbit to the second orbit, ಯಾವುದೇ ಫ್ಲೋರ್ ಇಂದ ನೀವು ಸೆಕೆಂಡ್ ಫ್ಲೋರಿಗೆ ಬಂದ್ರೆ ಯಾರು ಸಿಗ್ತಾರೆ? ಬಾಮರ್ ಅಂಕಲ್ ಸಿಗ್ತಾರೆ. This is Balmer series. If electrons are jumping from any orbit to the third orbit, then it is Paschen. Fourth orbit jump adre bracket, fifth adre P fund, sixth adre Humphrey. And Lyman series always ultraviolet region. They will be always in ultraviolet region. And this is very important, that is Balmer series are in visible region. Usually ಇದನ್ನ repeatedly ಕೇಳ್ತಿರ್ತಾರೆ. Which hydrogen spectrum are in visible region? Which series of hydrogen spectrum are in visible region? Balmer series are in visible region. Paschen, bracket, Pfund and Humphrey. All these are in infrared region, and all these are having different wavelength and frequency ranges. Although they are infrared region, they are having different frequency and wavelength ranges. This is very, very important. So this is about hydrogen spectrum. Excited electron jumps to different energy levels or different orbits. Then we call it as different series: Lyman series, Balmer series, Paschen, bracket, Pfund and Humphrey. Here, a scientist called Rydberg given the equation to calculate the wavelength of that hydrogen spectrum. What we have observed Lyman Balmer, that wavelength is lambda, can be calculated using Rydberg constant, that is RH into ಇಲ್ಲಿ z square ಬರ್ತದೆ for other than hydrogen atoms, 1 by n square. If this is for only for hydrogen, then z is equal to 1, therefore no need to write z here. See here, nu bar is nothing but wave number, and the relation between wave number and wavelength is that 1 by lambda, which is equal to wave number. Lambda is wavelength of emitted electromagnetic wave. Whatever the electromagnetic waves that are emitting, its wavelength is lambda. And n2 is the orbit number from which electron is getting de-excited. That's why electron is jumping. ಯಾವ ಫ್ಲೋರ್ ಇಂದ ಜಂಪ್ ಮಾಡ್ತಿದ್ದೀರಿ? That is n2. n1 is the orbit to which electron is going after de-excitation. ಯಾವ ಫ್ಲೋರ್ ಅಲ್ಲಿ ಇಳಿತಿದ್ದೀರಿ? ಮನೆ ಇಳಿತಿದ್ದೀರಾ, ಅಂಕಲ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಅದನ್ನ n1 ಅಂತ ಕರಿತೀವಿ. R is Rydberg constant. Its value is 109678 per centimeter. If it is in per meter, then it is 1.09 into 10 raised to 7 meter. It is in centimeter. See, in this equation, n1 is always 1 for Lyman series, because Lyman series ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ? When electron is jumping from any higher energy level to first orbit, any higher energy level to first orbit, then we call it as Lyman series. Therefore, for Balmer series, n1 value will be equal to 2. For Paschen series, n1 value will be equal to 3. For bracket, n1 value will be equal to 4, whereas for P fund, n1 value will be equal to 5. And n2 value, which may be anything greater than n1 value. N2 value is always greater than n1 value. It may be from 2 to infinity. For Balmer, it may be 3 to infinity. Paschen, it is 4 to infinity, and like that. And sometimes they may ask shortest wavelength. What is the shortest wavelength? What you have to substitute n2 as infinity. At that time, you have to substitute n2 as infinity. At which time? For shortest wavelength. Shortest wavelength. If they ask, find out the shortest wavelength of Balmer series. At that time, I have to substitute n1 equal to 2. See here, for Balmer, n1 equal to 2 and n2 equal to infinity. By substituting n2 equal to in this formula, we can find out 1 by lambda. But after finding 1 by lambda, we have to retrograde, then calculate lambda value, wavelength value. For longest wavelength, if they ask a longest wavelength, then we have to take n plus 1 value. The longest wavelength is n1 is equal to 1, we have to substitute. n2 will be 2. For Balmer series, longest wavelength is n1 is equal to 2 and n2 is equal to 3. We have to substitute one higher value than n1 value. This is about Rydberg's equation and Rydberg constant, and how to solve the problem. Let's solve one problem based on this equation. Before that, another important equation is that it is total number of spectral lines. Maximum possible number of transitions or lines for de-excitation from N2 to N1. N1 if it is electron is jumping, then how many number of lines are possible? Because see here, if electron is jumping from fourth orbit, first orbit 1 2 3 4, then hydrogen spectrum ಹಾಕ್ತಿದ್ದೀನಿ. If it is jumping from fourth to first orbit, there are many possibilities are there. It may jump to from fourth to first orbit, or it may jump from fourth to third and third to second and second to first orbit, and it may jump from fourth to second orbit and second to first orbit. This different possibilities are there for electrons to jump from any higher energy level to lower energy level. How to find out how many spectral lines or possible number of transition ಅಂತ ಹೇಳ್ಬೋದು, spectral lines are possible. n2 minus n1 into n2 minus n1 plus 1 divided by 2. This will be the equation. You should note the equation ಅನ್ನು note ಮಾಡ್ಕೊಳ್ರಿ. This will be important equation for us. Let us conclude here for this class, and from the next class we continue the same concept. Calculate the wave number and wavelength of alpha particles, or sorry, hydrogen spectral lines for different series. Then behavior, Heisenberg uncertainty principle we are going to study. Okay, thank you. Let us meet in the next class. Bye. Have a good day.